All right, let's have a look at the slope then. So, vertical rise over horizontal run would be the first way that we saw it. There's our number plane. So we've got a particular line. Got 2 points on there, and we want to find its slope. That's where we introduced the formula. It was a lot easier to do it via a formula. I think just a y2 minus y1 over x2 minus x1. In this case, unlike the distance formula, unlike the midpoint formula, the order is important, because if we do get them round the wrong way, the sign will change. So we do have to make sure they are in matching order. So our example over there, because I've chosen the 5, then I must put the 5 first in both the numerator and the denominator. So 5 minus 1 over 5 minus 2, which of course gives us 4/3. There's another way of finding slope, which of course is often forgotten. Let's put another line in there. There's the blue line. If I know the angle that that line makes with the x-axis, then I can find its slope as well. And so the slope is simply equal to the tan of theta, where theta is the angle of inclination, but it must go to the positive side of the x-axis. And the reason it must go to the positive side, because clearly this blue line, the way I've got it at the moment, would have a negative slope. So I need an obtuse angle, not an acute angle, if I'm going to go tan of the angle. So we need the obtuse one, the one going to the x side. So the slope of that particular one would be the tan of 120, which turns out to be minus √3. So that's the third way we could find the slope of a line. Of course, if I wanted to find the actual angle that the red line makes, I could use that formula in reverse. I know the slope is 4/3. We worked that out before. So the tan of, well, the inverse tan of 4/3 is not an exact value, but an approximation would be around about 53 degrees. Okay. Two lines are parallel if, and no, I have not spelt that wrong, they have the same slope. Okay, do we understand what the IFF way of spelling if means? Very good, which means? It means you can read the theorem both ways. So you can prove two lines have the same slope if you know they're parallel, but you can also prove they're parallel if you know they have the same slope. So you can read it backwards. Not all theorems you can do that with. So in other words, the two slopes are equal. M1 equals M2. Perpendicular, again, it is an if and only if condition. So negative inverse, or another way of thinking about that is they multiply together to give -1, the two slopes. So all right, well, I've got A, B, C, D, 4 points. Problem is I don't know the x value of my fourth point there. We're going to find it such that the two lines are parallel. Well, if they're parallel, the slopes are the same. So slope of AB turns out to be 2. Slope of CD, 2 on A minus 3, and we just solve that simple little equation. If the two slopes are equal, then 2 is 2 on A minus 3, so A minus 3 must be 1. We get A is 4. If they're perpendicular, then of course they've got to multiply together to give -1. So it's still the same two slopes, but we just get a different equation to solve. Now we've got 2 times 2 on A minus 3 is equal to -1. And that turns out A is -1 in that particular situation. Here's another classic question we see where they give you 3 vertices of a parallelogram and you've got to work out the fourth one. And a lot of people waste a lot of time with this type of question. So let's just draw a picture, plot in all the different points. And this is going to be a parallelogram. Now the naming of the parallelogram is important so we know where to place D. It's named A, B, C, D. Therefore D must be, well, if there's AB, you see D's got to be down here. Yep. Okay. Now, the way a lot of people approach this question is to do a lot of work. They'll find the equation of AB, find the equation, the slope of AB, find the slope of BC. From that they can work out the equation of AD and the equation of CD and solve them simultaneously. But we've got to use the symmetry of the shape. And that's what I've just drawn in here. I know to go from B to A, I go across 3 and down 5. Therefore, to go from C to D, I go across 3 and down 5. So therefore the point is 0, -10. Well, you're using the symmetry of the shape. The opposite sides are parallel. Yeah? Therefore, they've got the same slope. So if they have the same slope, the rise over run is the same. So rise over run going from B to A, well, I've gone run, then rise, so 3 across, 5 down. Then I must do exactly the same thing from C to D.
The sides are equal.
They're parallel.
And they're equal.
And they're equal, because it's a parallelogram.
So we just need to draw a diagram. Right.
Yeah, I mean, a diagram's going to help you work that out.
So we don't need to draw a diagram?
Now, if you have to prove 3 points are collinear, so A, B, and C are collinear. Way to do it, find the slope, just pick 2 of the points, A, B, pick another pair. Now, because you've only got 3 points and you're picking pairs, they must always have a point in common, in this case, A, the way I've described it. Well, if their slopes are the same, then they've got to be collinear. Because slopes being equal means they're parallel, but if they've got a common point, they can't be parallel, therefore they are the same line, collinear. All right, let's have a go at some of that.